All right, before the break, we went over our first example of this basic formula here. We initialize things, then we deal with the infinite loop, our main loop, basically. Optional shut down gracefully at the end, but if we just crash the program, it still ends the same. It's just what's going on internally in the hardware on that one. We want to worry about that. We do want to keep that in mind. And we saw our first example of a quick pass through this, but there's layers and layers and layers of this. The things that we're going to initialize and define, and then all these things we're going to do over and over again, that will usually be set up as objects by the prerequisites of this fashion. Some of y'all may not have seen object-oriented programming yet, but those things we're initializing and interacting with are objects that follow that same pattern. Initialize, runs one time, and then in infinite loop, what we do for each pass of the infinite loop. We'll see some of that in practice soon. We did our first example of it, and this isn't just the PyGame that we're starting out with. This is what all of our game engines do. If you go to game from scratch, you want to set that up. That's the first thing you want to set up. Same things we look at here. If you're coding a game from scratch, which I really like doing, kind of fun to make an engine. Takes a while, but maybe one of the ways one of my favorites to use is just the canvas tag in HTML. Just goes right on a web page, and then go over to JavaScript and set up a clock, something to keep the timing, set up the size of the canvas, and then some sort of start the event listener, and then just build the rest of the engine from there. These are already pre-built for us. One little note about the clock, though. So I said clock got ticked, then 60 means 60 frames per second. So 60 frames per second is 16.66666 milliseconds, so 16.7 milliseconds. Let's say 17 milliseconds. That fits nicely in a sentence. Does that mean every frame of our game takes 17 milliseconds? Okay, I see people saying no quickly. Yeah, that was very disastrous. That some early game engines tried that, and it can be disastrous because, well, obviously, if we can't get done in 17 milliseconds, then there's instructions that didn't get ran. That can be a problem. But if we finish too soon, like maybe nothing's happening, right? The user's just holding down the walk button, trying to get 3 kilometers away in a big open world. So there's not really any events to do. There's not much going on, and the computer's finishing it in 3 or 4 milliseconds every time. But if it does that, then that means there's 13 milliseconds of idle. It's not doing anything. The human brain starts to pick up on those over time. Even if it's just 3 or 4 milliseconds there at the end of the frame that are constantly, all the processing's done, the graphics have been updated, there's nothing going on. All those idle states start to add up, and our brain starts noticing, and it makes the game look jumpy. Y'all have probably encountered that playing games. Starts to make it look jumpy, or if we run out, if we don't get things done in the allotted time, it's even worse because then the game's going to crash. And instruction got missed. But it causes big problems. So what it is game engines try as hard as they can to average 60 frames per second. Some of them are going to be a little faster, some of them a little slower, and it's just going to internally it's going to try as hard as it can to average 60 frames per second, or 140 frames per second, or whatever we set it to. 12 frames per second. That's what Walt Disney used as the animations in the 50s, like Snow White. So you've probably seen the early Walt Disney animations when they were still experimenting on what a good frame was. 12 is what it ends up being. And by the time we got Snow White, it looked like fairly smooth movement. That's about the minute. You don't want to go slower than that. But that's incredibly slow for a computer. We can do way better than that. Add more stuff in, especially since we're not drawing every frame of our animation anymore. we usually have the computer do it. So that's the next thing to look at here is some points about animation. Did everybody see that announcement I sent out this morning about a software to install? So this is what I'm going to be using. You can use whatever you want. If you want to draw stuff in Microsoft Paint, that's fine. Microsoft Paint doesn't have transparent background, but they'll be okay, right? We're not doing the finished polished draft. Inkscape does vector graphics. Talked about that the other day. Instead of thinking of the point in space, we think about the arrow that goes from the origin to that point. So, like, how is that point located relative to our origin? Because then we can move that arrow anywhere we want. And then we can move that origin anywhere we want. And then our whole picture just moves all together as a whole. So Inkscape does scalable vector graphics. Internally to the machine, 2D and 3D vector graphics are the same, but in the text files, we handle them differently. So some sort of vector graphics. It allows us a lot of things. So for example, we do vector graphics, we don't have to draw every frame of the animation the way Walt Disney did. We can draw the picture once and then tell the computer to animate it. Like, make this move, because we have vectors. We have just the low. How do we get to those points in space so we can move that anywhere we want?
Move this point to this point. Okay.
Yep. And the computer fills in all the gaps, so we don't have to sit there and draw every single one, which can be kind of fun, and it's probably good practice and will help. And depending on the style of the game, that's going to be applicable at times. So you might want to practice that. But let's use vector graphics in this class for 2D and 3D, and we will see the animation soon. So I'm creating a new document here. If you just installed this morning, one thing you might want to do is change the default values, because for some reason it's set for millimeters. It's the open source alternative to Illustrator, and we don't have good print colors. They're okay. Right? If we use RGB, we can translate that to something on the printer, but it's not the same as if we actually had CMYK colors. Has everybody replaced the ink in a printer before? We have a C, M, Y, and K cartridge that needs replaced, or cartridges that need replaced. But we don't have an RGB cartridge in the printer. So using those other ones, that's what Adobe Illustrator has. But we're on screens here. Video games on the screen, not on a printer, so that won't matter.
How do you change the units?
So if you go to File and Document Properties, this is one we want to use a lot. You should see under Display, you should see the defaults are going to say millimeters here and here. So you probably want to change both of those to pixels.
Just PX.
Mm-hmm. Or inches, or whichever you want. Programmer pixels do not match screen pixels. They haven't since long before you all were born, like the old days of Apple IIs, when one is actual really, really large electrons, bundles of electrons in the cathode ray tubes, and flying green ones that basically just show text. That was the last time programmer pixels matched screen pixels, which uses as a unit. Some of the other ones. Yeah, we have multiple types, SIPs and DIPs, different types of independence, density independent, screen independent. It's just a label. Points are a traditional one. That one goes back to the Gutenberg press. 72 points in an inch. Lots of millimeters, inches. There's lots and lots of different ways we can measure. Pixels are just one of our units. But we all have different screen sizes, right? Everybody in here has a laptop, and there's a good chance all of us have slightly different pixel numbers on our screens these days. It's not like the cathode ray days. So change both of those to pixels. Set some sort of default value for your images, 512 by 512, and when we finish drawing it, we'll come back here and change this, and this will be the size of our file. So this is just a starting file. The little things on there, you can set a border. That way you know where the where the computer registers, because we're allowed to draw outside of our file, basically. It won't stop us from drawing outside of our area.
Always back there.
Yeah, but you probably want to set it to pixels because that's what we use when we program. And there's no save button, so just close this. They copied Adobe, so once you make a change, it's a knockoff of Adobe software. So when you make a change, just close the window. It's already changed.
You want some check too?
Checkerboard's nice if you like that. Some people, that's your personal preference. If you like the checkerboard background or just a plain background. And if you're new to graphics, you'll want to give both of them a try, like several times, right? Do on different days when you're in a bad mood, when you're in a good mood, when it's rainy, when it's sunny, try checkerboard. And on another day when you're in the same mood or something, try the solid background to see which one you prefer. It does take practice. Lots of different things. We can draw squares, circles, a few things. Notice these two icons down here. There's a pen. One that looks like a calligraphy pen. That's for drawing lines. Or we can do a bunch of straight lines.
No.
A spline is back in the days of drawing by paper, it was like a ruler and it had little feet along it so that engineers or drafters could put it in whatever shape and the feet would hold it in place and they could take it. So like a ruler that had feet on the long edge, so they would just plant like heavy rubber feet so it wouldn't move for professional drafters. And they could bend whatever curve, and then they had that curved edge to trace. Let me change this. There we go. So this one does lines, so it's spline, and we choose points like, say we put feet there and there. Oh, I'm the wrong thing, ain't I? This one's the spline. So we put feet like there and there and there. And when we trace it out, we get that curve. So it gives us fancy curves. But the name refers to an old tool, kind of outdated.
Very lost.
Oh, I was just showing the tool. Did you get this to open?
Yes, but I don't, it's like a small square, so not kind of square.
You can hold control and scroll. We'll be zooming. Oh, yeah. Yeah, I'm on the touchpad as well. If you have one of these pens, it works even better. Like some sort of graphics pen, those work really well here. I'm gonna click on the delete. Whoops. Delete that. So these would be good ones to start with. So that one looks like a calligraphy pen, because we can draw a bunch of straight lines and bring it together. And it's either the curved one or probably the third icon there, up there in the second row. That gives us straight lines, so then we can draw a bunch of straight lines to get whatever shape we want. And notice how it's got that mark there at the end to close it up. And when we close it, we get a shape that'll fill in and stuff. That'll be important. Right below that, though, you see the little pencil thing? Almost looks like the regular edit icon, only scribbles. So that's just the scribble all together. That's probably the one we should start with. That's it. Oh, I thought he was already in the Zoom call. He must have left it some way. So if you go to that pencil one, we can basically just start drawing our shape. So a player to start with. So I've had lots of practice with graphics, so I'm just going to draw some like a head, and I bring that over. That's the close spot. It turned it into one shape, one solid shape. So if I come over here and give that a skin color. If you don't see that menu that is over on the right, those come on and off. The arrow up at the top on the left, obviously select, so select that shape. This is why we want to use scalable vector graphics, because they're kept separate. We can always get back to stuff. They're all separate, independent things.
So I'm just not
Okay, you'll want to draw some pictures at some point, so that's why it's being recorded. So if you want to follow this later, kind of see what's going on. And
That's much appreciated.
it's being recorded. I'm not expecting you to get it the first day. There's a lot, so I'm pointing at this now, but we will point at it more than once. I think in week 3 is the plan when we will actually take one of these 2D images, like one picture of a character, and turn that into an animation. So we'll see that. Oh, okay, so let me bring up these menus. So you want to go to object and fill and stroke. That's going to be a really important menu over the side if you don't see that. So to draw these about halfway down, see those two.
I think I'm more on this.
It takes some practice. So I am on a touchpad right now. My pen's sitting right beside me. I have done this for a long time.
I can't even use a touchpad normally.
I'm pretty sure I've been doing this for longer than you all have been alive. So
Probably.
Probably because of me, because I'm 19.
Back in the late 1980s, graphics were one of my favorite things to do on computers. So when graphics were new on computers, I remember being excited when I had 3 colors.
You must have been really excited for the screensavers thing, weren't you?
We couldn't mix them. It's come along. It's been a long ways, but I have lots and lots of practice at this. Let me redraw that. So you'll want to practice that. Grab the little pencil, whether it's your mouse, you can get these type of pens and tablets for as cheap as like $15. I have a $30 one here, and I'm really, really happy with the 30. I think it was $28 one. Been really happy with that. So obviously, you get what you pay for. You can also get some that are several $100s. So, but those make it easier. You'll want to practice that. Grab the little pencil thing, and then drag it around. That'll work. And do that right. I just drew and deleted 4 or 5 of them. We're not on the final draft. It doesn't have to look perfect. We just need a stick man, basically. And then under fill and stroke, there's 2 things. We can choose colors or little X so we can turn off the outline and just see that part. But the big thing is we can do separate things. So now I can come in here still with that pencil and maybe draw a shirt for the character. Come across here, draw down the torso, something like this. That'll work. Fill in a shirt, and I'll just click one of these buttons, maybe red, and give it like an area. We're not the final draft. It doesn't have to look perfect. The quality of your art will not matter here. It takes a lot of practice to do that, right? But if you're interested in game development, you kind of need to start getting some practice with this. Even if you can just draw stickman. Can you get a stickman drawn?
I'd do a Pac-Man.
That'll work.
Is there a way to like, after you've drawn it, if you like messed up on a swell part, want to cut that a little bit off? So we do that.
Yes. So let me go back to. I'll do that on the chart. So, see the second one right here, right under the arrow that grabs.
Yeah.
If you click that, there's all the vertices. There's all the points. Because really, what we're doing is connect the dots. And you can move every single one of them. This is why we only use SVT graphics. We can move. We have complete control over any one of those points. And to draw here, Austin, you say he's drawing Pac-Man. That's perfect for a game.
I should not do that because it's copyright. So I'm thinking of something else.
It's fine for academia. It's very rare that copy. Actually, Pac-Man might be a public domain.
At this point, he probably is.
Pac-Man's older than me.
Mickey Mouse is on public domain, so.
We need to put it now.
Yeah, he is.
Those were re-established. I don't think they ever claimed long term
I remember.
Pac-Man.
Yeah. Well, I remember Mickey Mouse. They've been extending it for years, but I think the Supreme Court said no, you can't anymore. It's basically this is their last.
Because he's coming on 100.
Yeah.
like happy birthday.
It's basically at 100 year, 100
They're like,
now
well,
the
you
max.
can't extend it anymore.
It'll make it at least.
At least 3 generations later. So Walt Disney created Mickey Mouse. Walt Disney's last grandchild is elderly and going to pass soon. So nobody is alive. Nobody in the family is alive that knew him. It's kind of the limit. Okay, I'll go back to the pencil and draw some bands. I'll do the arm first. So let me do an arm. So I'm thinking like a t-shirt here. So I come down here, there's like the bottom of the sleeve. Come down a little further, draw the elbow. Maybe a big round thing for a hand. Come back up here and something like that for the sleeve. And then I can just click one of the colors at the bottom to switch it to that flesh color. So, well, things, but we can copy and paste. We have control over all these. So if I hit Control C and Control V, the normal copy and paste, there's 2 arms. So let me grab one of these. And right now we could just draw it, but drawing to the copy and paste thing there would be important for when we go to animate it. It's 2 arms, but one of them should be behind on the other side of the shirt, right? So that's the thing with SVG graphics. We can come up here to select one of the arms, go to Object, then we can lower it to the bottom, move it back behind things. We can bring it back up, and they're all independent objects, and we can come back and edit them. So even if you're going to use say things in your game, you probably want to originally do it in vector graphics and just export the thing afterwards. That way you can come back and edit. You have a way to edit it. Full control editing. There's some legs. Same thing for legs. We only need one. The other leg's just going to be a copy of it, right? So I'm drawing a leg, and now come forward and down, kind of like he's stepping, because maybe we'll come back and use the same one. Back up. And again, I've had lots and lots of practice at this. Be dark blue for some jeans. Graphics has been one of my favorite things since I was young, and I also have formal training in graphics from the engineering tech degree. So I have lots and lots of practice. It takes a lot of practice, but you just want some shape. Everybody try to draw some shape, because we're going to put it on the script, that window we made, and move it, and that'll be it for today. And then tomorrow, after we do that, then y'all want to play around with that. And this is Wednesday, isn't it? On Monday, we'll pick up from there and add in backgrounds and interactions and start doing more interesting things. Fill out the rest of this loop. But today we want to just start loading in pictures and maybe make it move. One picture moving in front of a background seems like a good start. The backgrounds load in the same way. Okay, I'll copy that, copy and paste. There's 2 legs there, so I'll take this and in Inkscape, if you click it again, so notice there's the move arrows to show all the different directions. If you click it again, those arrows turn so we can rotate it. So for the other leg, I'll just kind of rotate it back, and we clearly have 2 different legs. Maybe one of them's over here. I guess this one I could probably rotate forward a little. So click that, grab one of the little arrows, rotate that one a little more forward. Something like that. It ain't got to be perfect, but the general idea of a character. You want to start getting practice because you're interested in game development. We can download stuff for days, but you can't get away from art, and you're going to need some of it. And for your final project, you're required to do your own artwork, so you'll want to get some practice. But quality will not matter. What else do we need for a character? Shoes. Need some feet, so I'll just do a little. I'll just do a quick little oval for a foot. Maybe gray shoes. I move the zoom buttons out of the way. Give them some gray shoes. That'll work.
Oh, I can't even see that. We're mixing shoes.
Brown.
Yeah, I can't even see that really.
You see that?
There.
Okay. So some nice little leather loafers.
Yeah.
Copy that and paste that, and then move the other shoe back there. So a lot of copy and paste, different things. So I'm going to go ahead and that'll work, but it's probably kind of big, right? right now it was 512 by 512 pixels. That's what I had my default set at. Or we can see there if so now I'm gonna click and drag to highlight everything. Is that showing up on the screen?
How do you rotate an object?
Oh, if you click it once, you'll get the movement, and click it again,
Oh, okay, thank you.
and then you click it again, you go back to move. So it just toggles between. If you
Okay,
click on it, make it toggles between them.
thank you.
And then to move them forward and behind each other, just select the object, and under object, raise and lower. I select all of this. We need a good size. I'm going to go with maybe 64 pixels wide and 128 pixels tall. That sounds like a good size for a character. So these 4 boxes up here, these are going to be important. This one thing I'm saying, practice with graphics, and we just did everything with the pencil. The reason I'm saying that is if you're in your game, you're also going to be programming these graphics. Vector graphics are also kind of important to program because we can't really program a thing or a GIF. All we can do is we can write a program and say, throw this picture up there, but all we have is the whole picture. So we need vector graphics if we want to program. But notice these 4 boxes, the X and Y is the origin. So I'm going to set that to 0, 0. So start at 0, 0, and then 64 by 128. That sounds like a good size. But notice our file is still really, really big here. So I'm going to go back to the document properties, file, document properties. Oh, and after you set that, if you go to, notice there's a save template button. You might want to save something as a template after you set some document properties. But you want to, I didn't point that out at first because you want to play around with that and get used to stuff. It's very useful software. So I'm gonna switch this to that 64 by 128. So now our file size is the same as the character we do. So under file and document properties, and this is where we set like the pixel units. The width and height box there refers to the file. Which, if we would have left it 512 by 512, there was nothing there. So we wouldn't see it on the screen, but the computer would be processing it as a 512 by 512 image, even though ours was just up in that little bit thing in the corner. There's a lot of information, right? That's one thing. The reason I wanted to start off with this is we only have 8 weeks to introduce game development. So there's going to be a lot of information coming really, really quick.
Yeah, can you go back to can you basically just do that over I was finishing up
So the resize it.
how would you size the character? Yeah.
So what I drag to select all of it. And then up here, the X and Y box, that's where it's located. So maybe set that to 0, 0. And then the W and H is the size, width and height. And if they try to change together, hit the little padlock so that they're not, the padlock is preserve aspect ratio. So you might want to unlock so you can just make it to the size you want. And just type the numbers in there. Or you can make it whatever size you want. Just introducing things. We will see this more than once. We're not, this isn't the only image we're going to use this semester.
And then you do the document properties to shrink the entire
Document properties to bring the whole file down to 64 by 128. Right, now I'm going to save this and make sure you save it in the project we just made. So I have this, my little scratch folder here on my desktop, class example. For good form, I'm going to go ahead and make a new folder and call it images, because we don't have much going on in our first example. So we could put it in the same file, but it's not going to be long before we get to much bigger games where we're going to want to organize things. Like we'll have lots of images and lots of things. So we want to get in the practice of organizing things now, form the habits to start with. And I'll just call this player. Sounds like a good name for it. So now, documents.
Is there a certain type of like save as type?
Go ahead and save it as an SVG. Which I actually saved mine in the wrong spot. Move that to the folder I just created because I just talked a bunch about why to put it in a folder and then saved it somewhere else. So I put it in there. Notice player.svg. I'm going to use a regular text editor here. I've been using idle. I'm just going to open the Sublime text editor. That's the one I use just to look at that SVG. And then the dot just means current directory. Dot is how we type the name of the folder we're currently in. That works on just about any system. So here's that Python script we wrote. We already saw that. If I go in the images folder and open the SVG, if you haven't seen this before, it is a markup language.
How do we open this up again?
So any text editor you have. So if you have a text editor on your computer.
Yeah, but what if you do it? Just right click it or what do you?
Oh, you can do it that way. I went to the address bar and opened Sublime. But how do you normally open text files? If you just open it in like Notepad, regular Notepad, I probably could have done that instead of going to the fancy text editor. Right click and right click and open with, and by default, it's going to try to open it somewhere where you can see the image because it's SVG file. So if you choose another one, just choose one of your text editors, Notepad or Sublime. I'll go Sublime here. It's a markup language, so we use tags. If you haven't seen it before, obviously the computer's writing it. We don't have to worry about all this. But notice, let me turn WordWrap on. Oh, I'll leave WordWrap on. So there's a bunch of setup stuff. Right? We have some SVG graphics. Here's how big they are. Blah blah blah. A bunch of stuff. And then we get down here, and there's this thing path, and here's a whole bunch of numbers. Right? That's a bunch of numbers. I mean, we're programmers. We know what to do if we have a big collection of numbers. We can do stuff with that, right? So this is the type of graphics we can program in our games. If we want to, instead of our character stopping when it hits a wall, if we want our character to like get squished when he hits the wall, Bugs Bunny style or Wile E. Coyote style, right? When he runs into the cliff, he goes flat. We can just grab these numbers and reprogram them to do that. So that's the important part of using that. Otherwise, it's markup language in the text file. Internally, 2D and 3D are stored the same way. To the machine, they're the same. But in human, for the text file, the human workable one, we use two different formats. But for 2D, a markup language has become the most popular. Any questions about graphics? That makes sense? Takes a lot of practice. You want to just start getting practice. Just start getting some practice. It does not, for your final project, it has to be your artwork. It does not have to be good artwork. If all you can draw is a stick man, that's fine. If you can just draw a circle. Oops, I apparently erased something in the file. There we go. So if we come back over here, let's put that image in. So that's up in our initialization section. So I'll come up here before we get to the main loop and initialize our character. I'll call it player sprite, which I just made up that variable name. That's the way to refer to it. And I'll set that to PyGame. I didn't do anything fancy when I was getting ready to, nope. PyGame, that module we imported, or our game engine. It's gonna be something similar on any of them. Whatever game engine we're working in, it's gonna have a way to load images. For PyGame, it's pygame.image.load. And then we need the name of our file inside parentheses. And the file is in the images folder. called player.svg. At least that's where I saved it. If you called it something different and stuck it in a different folder, just the file path, the relative file path. How does it get to that file from where this script is located?
Okay, so it just need to be then the file that's, okay.
If you put them in the same folder, you just need the file name. Yeah, the basically to do a file path was the entire reason I put it in the folder. Really probably not necessary to organize it in this example. So that gets our images, the sprite. Probably need a place to put it, right? Some coordinates. X coordinates and Y coordinates, or again, like our screen size, we want to work in vectors, so we want those numbers to come together. So let's set up a tuple. So like player chords, sounds like a good name for it. This one is going to change, right? We are going to change the X and Y coordinates for our player. So we probably want to use a list so that we can change it. So square brackets on this one. Our window's not going to change, so we'll leave that the same. And since it's not going to change, it's better in RAM. That was a big reason for doing that. It's more efficient on RAM because it doesn't waste a bunch of space getting ready to change on something that can't be changed. But our coordinates are definitely going to change. So I'm just going to put a random starting point, our XY coordinates. That's where we'll be located at. But we want them kept together like that. And you just want to ask, is it going to change? Okay, I'll put that in a comment. Tuple, since it won't change. And down here, list, since it will change. Either way, we just want to we work with vectors a lot. So we need to keep track of which ones are vectors. Hopefully by this point, you're already seeing why PyGame is a nice one to start with. Everything has nice names, seems to follow some conventions, and it follows all the. We're using this to introduce game engines. We're not going to talk about PyGame for long, but the stuff we're talking about here is still going to apply everywhere. If we opened up Unreal, we could apply this stuff there. I'm not going to open that up on these lab computers though, so figured that one wasn't very feasible. Might look at it some at the end. At least look at it and see what's consistent. What's that?
Will these not be able to handle Unreal or?
The ones in school bot? No. I'm hoping to get GPUs. I've made several requests for like grants and benefactors and budgets and all sorts of stuff to try to get GPUs, but don't have GPUs yet. So Unreal would probably just give us a warning message, but I don't think these are the ones this Ivy Tech bought for every campus across the state. School of IT does get the newest computers. So in 3 years, these computers will go to the other computer labs and we'll get new ones. And what's in the other computer labs, the regular Ivy Tech computer labs, like this at every Ivy Tech campus, is what used to be in the School of IT labs. So to put this on the screen, there's a method we use that is almost always handled for us. Oh, not PyGame, no. Scene, remember we created that thing scene up here, which the actual window we're looking at. And we're looking at, I called it scene. That just makes sense in my mind. And that's what most of our game engines call it. Scene has a method in it called BLIT. This stands for block transfer. For sure, the I is just there to make it look nice. Block transfer is what a GPU does. Doesn't calculate this right, pixel 1, pixel 2, pixel 30, pixel 4. It says, okay, here's a bunch of pixels. Let's move them all at once. Take all of these and throw them all, and they're still in the same order, same fashion. We're just going to put them over here instead. So this is what all of our game engines will work with: block transfer. In PyGame, it's usually handled in the background. Everything else we'll see this semester, it's handled in the background. But block transfer, and what do we want to block transfer? We can see in the predictive text the source and the destination. So I'm going to take the player sprite and transfer it to those player chords. That makes sense. Hopefully, at least in the back of your mind, it's forming a pattern. This isn't going to run right now, but I like to show errors. Those who haven't seen me in class before, I do like to show errors, especially the most common ones. So if you're looking at textbooks and tutorials, you see that finished, polished version, but that's not how it goes when we write code. I think y'all are well aware of that. So I like to look at the most common errors, including this one that won't actually give us an error message. So if I run this now, we'll still see what we saw earlier, just blank screens. Where's the player? Did the block transfer, loaded in the image, so blit that to those coordinates we set up, but it's not on here. There's no error message, so I assume it's typed correctly. Not a typo, no sort of type error or anything like that. So that's a very common error. One of those that after years and years and years of making games, I feel pretty confident saying that you will continue to forget this for years and years and years, because one of the trickiest things. But the last two lines here. Remember all the stuff in the main loop? We listen for events, react to events. We'll get to that for our moving, right? Our WASD events before we wrap up today. Physics, we don't have anything to interact with yet, so we'll see boundaries next Monday. The normal movements, that sounds like a normal movement. What's the last thing on our list?
Graphics.
That's an easy one to forget. They haven't updated the graphics yet. So in PyGame, it's just pygame.display.flip. I'll just say what it is. And kind of like the flipbook animations, I guess that's where they got the name from. So take our display and flip. So like flip through the flip book. Oh, I got that book here. Flipping through all the pages, and it's a good way to refer to an animation. So now our thing should run. So I'll give it a save and hit F5 or function F5. My computer's inconsistent. There's a character. So let's start. Right, we got a character on the screen. It's reloading that every 60 seconds. It's putting it on there 60 times per second. We can't do anything yet. So we want to see our first events. And that's what I wanted to get up through that at least today. And then we'll add in a background next time and come up with some sort of story for this character to do. Maybe collect coins, because we're in a classroom setting, so we need something non-violent. And every time I start doing games, I often have trouble coming up with things that are classroom appropriate. So collecting coins is a good non-violent thing we could do. But up here where we're checking for events, right? First thing in our loop, we just updated the graphics so the player knows where the character is currently at and needs to react to that. Move somehow. Actually, let me run this real quick. So we have a couple options. Oh, yeah, save it, run. I did kind of a side view. I was thinking of a sort of angled down overhead map view for our example. But where we're at right now, we could just as easily go to a platformer.
Let's say technically the old games were a lot of times top down, but you still see the side of the character.
Yeah, there's different ways.
They
Right?
want to show the character, but at the same time they want a top down view. So
Yeah, there's different images, but if we put just a constant movement downward until it hits something, that's all gravity is. It's an acceleration. It's actually built into the game engine, but if we just made it start falling, put some ground under it, then we can make a platform. Put a background under it and move around, and we can do our WASD keys. That's what I was thinking. We have lots of options here, right? We could make that a mob or an NPC and make this a first player game. And when we push our keys, that gets bigger and closer to us. We have lots and lots of options right now. All we have is an image on there. But that's the sort of stuff you want to play around with, and I'm going to make sure there's at least an hour to do that. Probably have more than that because there's just one more thing I wanted to add for that. Back in our events, whichever one we choose to go with, the player can see that thing on there. The human can see that thing on there. It's going to hit a key press. So that's an event we can check, right? So if event.type, I want to go ahead and run both of these because maybe we want to do something the last frame before we come back around instead of an if, elif, because that would be one or the other. Right here, I want to check both of them. So if event.type, I want to check if they hit the little X or if they pressed a key. Equal, or in Python, so you could say is. I prefer to type equal, but a lot of people like is because that makes sense and looks nice. If that is PyGame dot, and we have several options. I'm going to pull them up here just to mention this.
Oh boy.
When you're first getting started, you all probably know this. You're going to look at tutorials, YouTube videos, things like that. Keep in mind that tutorials only have the first couple steps, usually simplified versions. They don't show the whole picture. The documentation, that's the user manual. That shows everything. Tutorials also go out of date. Python 3.12 just came out a week and a half ago, which means there's some things removed from the language and other things added to the language. So unless the tutorial was made in the last week and a half, we can't guarantee that it's an accurate tutorial for Python right now. Probably is, because there was only high level changes in the beginning. Weren't any introductory changes to Python, but that did just happen to Java this semester. In September 24th of this year, Java changed the most basic format on, the most basic format, something that the students see on day one. Change. We didn't see it in the class because we don't want to be beta testers in the classroom, but it's coming forward. But the documentation is the user manual, the whole picture. Always look at the documentation first. I don't know who picked colors for PyGame's documentation. Might want to change your screen to black and white. Okay. Quickly change to black and white if you need to read PyGame documentation. I don't know who went with those colors, but look through here and start seeing stuff. And it's going to look confusing. It's going to be hard. Maybe search for the exact PyGame.key. Yeah, this is probably getting right to it. PyGame key, version 2.06. So we got key get focused, key pressed, key mods, key repeat, key name, key code, lots of different things about keys we can look at. And that's what I want to look at. There's a lot there. It's going to be overwhelming and confusing. But this is the user manual. This is what you need to learn to read in order to learn new languages. Right. Second half of the semester, when we get to a big game engine or game maker, a lot of people in 3 weeks, game maker, a lot of people really love game makers, but just in general, look at the documentation first. It's not going to make a lick of sense, but use the tutorial to learn to read the documentation. Then you know how to learn. Then you learn how to use the user manual, not just copy one line of code. It's like, okay, this doesn't make sense. Key press in PyGame, PyGame, then go over here and find a nice little video, which there's going to be there's, yeah, YouTube's got tens and tens of thousands. We watch the video and it's like, oh, okay, that makes sense. And go look back over here and be like, oh, okay, that's what they were saying when they had this start text input. What I just randomly pick one, but use the tutorial to learn to read the user manual, and then you can figure out whatever you need. And you don't get stuck looking at tutorials. I'm gonna use key down. We have several there. Press, down, and release, or up. Key down. No. Yeah, key down is when we first hit it. Key press is when we're holding it down, and key up is when we release it. Those are going to be the three main ones you want. You want that to happen is when we first hit the key, which is basically once per frame, because a key press could happen several times per frame, right? If we're holding that, we're at 60 frames per second. If we hold the D key down for all 17 milliseconds, that holding it down should be more than one press. So down, the press or release, and I've seen a lot of head nods. Everybody says the gamers. You don't know the difference between. Yeah, I see head nods. Y'all know the difference between the press and the release, and when we would, or the push, the hold, or release. Different names and different legends, but one of those. If it is, then we need to see what it is. Like if, what here? Yeah, I'll just type this event.key is equal to, and we need some constants, which were on that page that I just closed. We go back to the documentation, so we actually look up something there. Key press and PyGame. I scrolled down to it, knowing that I was going to point out it in a moment, and then close it. So here's our keys. It's PyGame.this. So PyGame.k _ backspace. PyGame.k _ tab. The numbers k _2, k _3. But here's the ones we probably want, right? WASD seems like a good starting point. K _ capital K _ lowercase letter. Might want to pay attention to that chart because that's, see, it's got the whole keyboard. We'll see input managers before long. For now, we'll just do a key press, which is not the best way to handle this actually. Because if somebody plugs up a PlayStation controller, there's not an A key on the PlayStation controller, right? We really want to do it in a way that would work for both. So we will see that very, very soon, but not in our first example. So if it's, whoops, my cursor was not where I thought it was. On screen. Cursor still wasn't where I thought it was. So that PyGame module has something called K _ A. I like to type both of these. I'm going to copy that line. Paste. Paste. And if you haven't seen this before in programming, this happens a lot, right? We have a bunch of lines that are very, very similar. Need a little bit of editing done. It's only one change on this one, but it's actually more productive to work down the columns than across. Say we had several changes, right? And you need to change this, need to change this word, and then this word. So 2 changes. We have to set our frame of mind for this change. Make it read across, set our frame of mind for this change. Then change our main back. Frame our mindset back to the first one. And again, and we're constantly changing our mind back and forth. But if we work down the columns, we just go this one, then this one, then this one, then this one, to make all those changes. Then we only change our mindset once, our frame of mind, after thinking about it, change it once and come down here and do these. S, W, D, or whatever order you want to put them in. and it becomes more productive. That's a common thing to happen. Also, if you're doing that, it's more productive to work right to left because maybe this needed change to something else. And I'll put a couple S's there. But notice how if we start at the left, the stuff on the right no longer lines up like it did. So if you start on the right, everything still lines up. And you're not changing your mindset as much. Then we can come back and do the stuff in between. Because it's programming, it has to be in a certain order at the end, but the order the computer needs it in is probably not the order we think about it in. And it's a lot better to work on it in the order we think in. Like, work on it your way because you can move the cursor anywhere and just make sure it's in the right order for the computer by the end. Most of our examples are going to have stuff like that. We'll be bouncing all over the text file. If you haven't had any class before for programming examples, we're bouncing around back and forth. But everything's recorded, so you can also preview it in the classroom and then pause the recording later after class. Because pretty much every day we will have extra time. When we look at 3D animations, we might burn up all our time. It'll be pretty close to 450 by the time we finish the 3D animation day. But otherwise, we'll have time to work every day. So if it's the A key, what are we going to do? Yeah, actually, I almost thought about that. Let me do what he, because I put those in the wrong order, didn't I? Should be WASD. So the first one should be up, but I typed it in arbitrary order. That's probably going to cause a bug later because that would have been my first thought too. W's first. So we go up, and then later if we come back and to fix a problem or add features, might look at the wrong spot. So anytime you see something like that, stumble across something like that, go ahead and fix it. It's like, okay, this is going to be a problem later. I need to fix it now. Yes. So up is probably first. Is up a Y or an X? Yes. I'm gonna draw a picture real quick. I meant to draw a picture and let's see. There's a spot over here. So what we've got here is we have our vector graphics, right? So let's do a bunch of circles like this. So there's our character. And what we actually have is the vector. So we're going from that origin to each one of these pixels. I'll just draw a couple. I'm not going to draw every single arrow, but that's how our graphics are stored, right? And then we have our window. And there's also an origin. Oh, computers use top left as 0, 0, so different than your math class. Yeah, like in math class, origins in the middle, or we think about the first quadrant where. Oh yeah. Yeah, we start up in the top left. It's like lines on a page. Lines increase as we go down, but in math class, your math teacher always drew it with the Y going up, right? But on computers, it goes down. I've heard a couple different stories, but here's our situation. Actually, our player was at 123, 123, wasn't it? 123, 123. And then that is based off of our origin is relative to the screen origin. So what do we need to do in order to move up?
Increase the Y-axis.
Yes. So Y, if we push that key, how much should we move up? This is a trick question. 10 pixels is a good guess, because yeah, we want to guess. It's different every situation. Take a guess. Once you take your first guess, see what it does, and then a few trial and error. You want to find the number.
Just set speed.
Find the number that feels the right way.
Mm. Yeah. So we would set a speed and then find the best number.
But
We'll see that soon. We've already been at our first example for a minute, so let's just hard code 10 in. Or yeah, and then we'll make improvements and stuff. So before we load our character at that spot, if we hit the W, then we need that player chords to change by 10. Or if y'all heard Austin on the Zoom call, so player chords, index 0 is our X and index 1 is our Y. Everybody okay with that? From how we created it up here?
Where's your zero?
X is the first one, Y is the second one.
Yeah. So dictionaries can be nice. Then we have strings instead of numbers to index it. Then we can just call them X and Y. Makes the code look so much neater. But he's gonna I erased the 0. We want because 0 would be the X.
Oh, okay.
If we push W, we only want to change the Y.
I made a comment. That's fine.
So that we will increase or decrease by 10.
Would that be
Increase if you're going.
You're going up.
Yeah.
No, it's decreased.
You're moving closer to zero, so
Mm.
it's gonna be.
So it's opposite of our math class. So 1, 2, 3, 1, 2, 3, 4.
Oh, yeah, it's getting closer to zero.
But we start at the top left and go down.
It's because the numbers.
Like numbers on a page.
It's because the numbers, the coordinate numbers are not negative, so it's, you get it puts a little bit.
Mhm. Yeah, so if we want to go up, we go negative 10. One of the stories of why that came about is one of the early uses of graphics, or one that really applies to us really well, is gravity goes down, right? We're going to base everything off gravity. Anybody who's had a physics 101 class might know this. The labels are arbitrary. We can make them whatever it is. And if we make gravity positive, call gravity the positive direction, then we have a lot less negative signs to worry about. And negative signs are problematic. Everybody knows that in math class, right? They will disappear on us. Negative signs are problems. So to go up, we need to subtract 10. Like lines on the page. Lines in our text file.
It's getting closer to zero.
Yeah, we want to get closer to 0 or going to the negative. 0 is just the top of the screen. We can,
You can fly off screen.
yeah, we go past it. But yeah. So we'll do the same thing on all of them. And copy and paste is good. Right? Let's yeah. I was gonna copy it, but if we push the A key, which direction are we moving?
Negative. Well,
That could be the left.
Left. So negative X. Which index was that?
Zero.
0.
Yes, exactly. So index 0. Left is negative X, so we'll go down by 10. Minus equals 10. Everybody seen that shorthand before? The chords minus equals is the same as player chords equals player chords minus 10. It's a shortcut we have in like every programming language. Increment and decrement, multiply and divide. One of the most common things we do is reassign. So I call it the reassignment operator. A lot of textbooks just call it assignment operator, but we can't do any initial assignments.
I think they call it an operation method too.
Yeah, there's a lot of names. I say reassignment. We're going to reassign player chords by 10 less than what it was. S. Which way are we moving if we do S?
Moving down.
Down. So X or Y.
That'd be Y plus 10.
So 10, which only leaves us one thing left. So we press D. got to be the other one. Player chords, the X value, so index 0, increments by 10. Save that, give it a run.
I don't think I would do anything, I just tried it. Thank you. I can try again.
Working. I have to keep it in the D key
Oh, that's, oh, D, okay. So,
or S
yeah, I
or
forgot.
A.
Now
Probably.
we got another problem though.
S. Yeah, because we're doing block transfers, but we never clear it out, right? So we need a clear. What did I do when I was getting ready?
Oh, yeah, it is.
Oh, when I was getting ready, I just did I just redrew the background. For example, I already had the background in there, so I just drew the background because we just draw stuff on top of it. So we just need a big box.
They're not delete old image or you just have to cover it.
There probably is clear in PyGame. It's only one layer thick, so usually we would redraw the background. When we redraw the background, there's nothing else. It replaces what was there. So the block transfer, we take that block of pixels and put it somewhere else and replace whatever was there.
Right, so normally you would reload the background and then reload the sprite, and they would just basically be flipping over each other constantly, deleting the old one.
Yes. So there's a fill method. That's what I was going to do. Fill and then an RGB color. But y'all know the process. I just wanted to look it up because that's something we're going to do, right? And it goes in order. So the first thing we did is behind. So scene.fill white or black, or we could put a random color in there every time. That would probably be dizzying, right? Black is all zeros, right? Remember the binaries, think back to binary code instead of the decimals, ones and zeros, but really on and all. So just like the room here, if we turn all the light switches off, it's dark. Turn all the light switches on, it's light. So all zeros is black, all ones is white. If there's equal amounts of red, green, and blue, so then we just need a RGB value. It needs to go in as a tuple. So red, green, and blue, like we say like 32, 32, 32, that's it. That'd be a gray. Equal amounts of red, green, and blue or something on the gray scale. I'll put a space here. It goes in as a tuple, which is going in as a parameter, so we need the parentheses inside of with a tuple inside the parentheses for the parameter. All zeros is black. 136, 136, 24. This will be a bright yellow. This probably won't look so good. But run that. Oh, that's kind of, yeah, I was expecting more bright yellow. Oh, yeah. So now, notice it does it over every time. So it redraws the background. And then we redraw the character.
And effectively just covers the old model of the character with the background. Basically.
Yes. I got too much blue in it. I was expecting a bright yellow, and then I was going to go to a color like that. Oh, like that. It's sort of a green background, so it looks like he's walking on something. We'll do a picture or something soon, but so we have an hour and 5 minutes left. I got us something on there. We have to tap the key now. But that gets us a start, right? y'all can put more images on there and we'll see interaction, maybe hold the keys down. Should we do hold the keys down? It's only one line. So go up to the top in the initialization. Maybe right after the clock. If we say PyGame dot key p dot key dot underscore set. I just said that all kinds of wrong. Been talking too long. PyGame dot key dot set underscore repeat. And then we need to give it a couple numbers. The first one is how long to wait before repeating. We're at 60 frames per second, so every frame 17 seconds. So we probably don't want to try to match that exactly. Right? That would so something less than that, it'll kind of start there. Pull up the numbers. PyGame set repeat. Oh, actually, it's on this page, isn't it? That underscore repeat. Already on that page, so let's check the manual, see what it says. So delay and interval. How often are we going to check to see if the key is still held down? We probably don't want to try to match frames precisely. For one, we're at 60 frames per second, which is a repeating decimal. So we can't match that exactly. And then the interval, how long does it have to be held down for in order to count? Maybe, so let's check every 10 seconds to see if it's still being held down. And they've had to hold it down for at least 7 milliseconds. Every 10 milliseconds, we'll look to see if it's been held down for at least 7 seconds. If so, they don't have to release and press again. Make sense? As he head nods in the classroom, hopefully that's yeah.
Oh, and it's
Milliseconds.
speed is going like this.
Yes. So 10 is probably too high. Bless you. Run that. Oh yeah. It's a fast reaction time for that.
I like half that one.
So that's what that thing I said was a trick question. Right? Ask how much we should move, and so this time we probably want to set this variable, right? You have to come through and retype everyone. I just wanted you mentioned it. It was mentioned, and hopefully others of you all thought the same thing. But I just wanted to remind you of that error. So player speed 5 sounds good. And now we're going to copy that variable, player speed, and in all these places we put 10. I'll put player speed. The first one is just a guess because it's going to be relative to your animations, right? Speed is going to be if your speed doesn't match the step size in the character's animation, it's going to look off. We'll talk about animation soon, but you want to start with still images. Some people take it even further. I like to do a little bit of something like what we did here, a very rough draft of a character that looks character shaped. Some people won't even do that much. Great big bugs can hide behind little bitty animations. We could have a character just standing there waving their hand like this, doing almost nothing. And we could work a massive bug in the program and people wouldn't notice. Same reason stage magicians can get away with so much. A little bit of distraction goes a long way. Some people take it even further and say your first draft of the game should always be done with rectangles and circles. You don't want any details there at all because massive bugs can hide behind tiny animations. You just won't see them. But it's the same reason.
Sometimes they purposefully do that.
So 5 is still pretty fast, depending on what else is going on in the game. Right. So, but now that it's a variable, we can just change that variable, find a good speed. I'm gonna go to 2. Give me a floating point number. F5. It's slow, but also slow is relative to what's going on around it. What else is going to be on our world? Is it? Because if I push up, or I'll do it to the left. If I need to move to my right, 1,000, I can only take about a walking speed's only about 2.5 steps there in 1 second. But from the size of that character, if I push right, that's definitely probably a distance more than 2.5 steps in 1 second.
He's scurrying.
Yes, he's running. He's sprinting. So we can't really say whether it's too fast or too slow until we get something else moving in here.
Because of the bits in your game.
When we get the mobs in there, then the speed of the mobs will definitely define whether he's too fast. If he can't catch up with them or if he can't escape from them, that's a problem. But yeah, we need more details. We don't have the whole picture. And I want to end on that note. Until it comes together, it's really hard to do stuff. You'll think something's perfect there at early steps. And then later, when you start adding other things in, you'll notice it's way, way off. There's constant back and forth. It's not like business software where you debug line 17 and line 17 is good no matter how many more thousands of lines you're up. We need all this stuff has to interact, and we're constantly going through here. So that's one of the reasons game development is very time consuming. Takes practice. And right now we have an hour left in our scheduled time. Might be a good time to get that practice, but we've been at it for a couple hours, so it might also be a good time to rest our eyes and all that. But start with that basic practice, and we're going to carry it quite a bit further very, very quickly. Starting next week. Next week is just all examples like this. There's 2 or 3 small pictures like that I put on the board that'll probably take us 10 minutes in total to write them out. But practice with graphics. Put things on the screen, try a different one, try a couple different things. Like we drew a player walking around a green meadow, I guess. Something green. Put a fish in a pond, put a plane in the sky. Just a couple different things, right? A background, maybe put an actual background instead of that fill color. It would load in the same way as the player sprite. Just draw the image and load it in. Monday, we'll look at lining images up. So that when we have small squares and we put them next to each other, the left side of the image lines up with the right side. Top side lines up with the bottom side. We'll see how to do that. Then we don't have to make great big huge worlds. We can just make little pieces of the world and put them next to each other. That's a really useful thing. We'll see some interaction. But for now, try to get some practice with this. Take it a couple steps further, see what you can do. Maybe start on the tutorials. They do use object-oriented stuff in that tutorial. But like I said earlier, if you want to do your own thing, we're going to walk through sort of a working example. So if you want to replicate some classic game, I mentioned Space Invaders the other day. Probably an early game, right? I don't mean classic as in 2018, where video games have already evolved for 40 years, 50 years. Something from like the early 80s up to about early Nintendo. Super Nintendo is the latest. But really the 1970s arcades, Space Invaders, Asteroids, Pac-Man. Those very early games would be quite reasonable in our time scale and easy to do. That would be acceptable if you want to take what we do in class and try to replicate that, because those pieces you figure out along the way will be far more productive as far as learning game development. Any questions about today's stuff? First example, everybody get something working. We will see a lot more, and then we will see how this generalizes. Looking at here, we're looking at game engines in general. That's why we're going to look at several. We'll see how our big game engines follow this same pattern. We just use different syntax and different tool to interact with them. I'll give it a few seconds so that anybody on the Zoom call has time to unmute if you have questions.
Hi. Quick question. I know you've shown this a couple times already. I'm still struggling to get the the import PyGame thing working with the variable.
Okay, yes, we can do that after, I'll stop the recording and we'll go over that again. Any other questions that need to be on the recording? And then I'll stop it and answer that for Max. Or anybody else that wants to see it? Okay. I'll stop the recording. If you don't want to stick around and watch that other part, head out and I will see you on Monday and we'll continue from here.